morning, but since there was no homework, I assume there wouldn't be any watching really anyway. I already answered that question, Riley, but you don't pay attention enough, so you need to speak us in. No, but I said it this period to the class. We'll see. Find out from your peers. All right, guys. We're going to our workbook. I'm going to start off. Did we finish the problem one yesterday? No. Okay. We're not going to get through a bunch of them. I want to look at this graphically, and it will really help us understand how to do these problems. So, internet's being a little slow today. There it goes. I think. Problem is, I just always know exactly where I need to click, so it's like, you're going too fast. All right. We're going to try to get through 6. We are going to try to get through 6. Joseph, I don't mind you being in here, but let's not distract Elias. Elias, don't just stare lovingly into Joseph's eyes. Okay? So, if we understand this graphically, everything comes into focus, pardon the pun. So, let's make sure we understand. So, remember the A value of a parabola is positive if it's facing up or if it's going to be facing right. Up or right, A is positive. Down or left, A is negative. Up, right, positive. Down, left, negative. So we're going to take a look right now. That's why we're going to do these. So by doing it the way I'm doing it, I don't need to it just says find the equation of the parabola, write the equation in standard form. That's the same direction. I don't need to listen to all the other gobbledygook in these directions. By going through my method, you're going to understand what you need every single time. So we're going to copy over question 1, and you're going to need some room because we're going to graph these a little bit. They're not going to be perfect graphs. They do not need to be perfect, but you need to be able to understand what you're looking at. So a big thing, something I said, there's a lot of math bouncing around in my brain, and I say it different every time I teach it, and that includes between 3rd period and 6th period. So something I said 3rd period today that really resonated with the kids was wherever my focus is compared to my directrix is the way the parabola opens. Wherever the focus is when compared to the directrix is the way the parabola opens. Okay? So right now we've got a focus at 6, 0 and a directrix at x equals -3. Don't forget an x equals line is vertical. X equals is vertical. Okay? So Solaria, why did I say it like that? Solaria. Solaria. So, you've got the focus at 6, 0, 1, 2, 3, 4, 5, 6. We good right there? There's our focus. And are you okay with our directrix? Is that vertical line x equals -3? You do not have to have a perfect graph. I'm just doing it because I want you guys to understand the process that I'm doing. Are you okay? Okay. So, Solaria, the focus, is it to the right, to the left, above, or below the directrix? The focus, is it right, left, above, or below the directrix, which is the dotted line? To the right. So our parabola opens to the right. That's it. Okay. Away from the directrix is a great way. But careful because to the left could also be away from the directrix, but the focus determines what side it opens on. Destiny? It will. It will. I don't know exactly how much, but it will. I'm also going to go over a short lesson I went over 3rd period in a bit, but for now let's go over the process. So here I need h when we look at our formula for a sideways opening, which is a horizontal parabola, I look at my chart and a horizontal parabola looks like x equals a times y minus k squared plus h. I need three letters. I need a, k, and h. K and h are my what? The coordinates of my vertex. The coordinates of the vertex of my parabola. So if I get the vertex, I have 2 out of 3 of my variables. Let's get the vertex. It's the easiest thing in the world to get if I've got the focus and the directrix. Where is the focus and the directrix? Or, sorry. Directly in between the directrix and the focus. What is the distance from the directrix to the focus? Sione? 9. We did start this one yesterday, huh? Yeah. Okay, so we pretty much finished it, but it's all right. It's a review. It's a good place to start. So from here to here is 9. So the vertex is going to be exactly halfway. So half of 9. So that's 9. Okay. So divided by 2, we're going to go 4.5. 1, 2, 3, 4.5 right there. 4.5. Right. And we were yesterday. Somebody. That's right. It's. I'm recalling now. Somebody said that magic thing. It was Holly and Sione combined. I recall completely now. One of you, it was Sione, said that distance is 1 over 4a, and Holly said that distance is 4.5. And so when two things are the same, they are equal. Okay. So audio is like, I remember that. All right. So 4.5 equals 1 over a. 1 over 4a. My apologies. And then I showed you cross multiplication, but it's the same thing. In order to get rid of something in the denominator, I could just simply multiply by that denominator. You're going to do this so many times it's sickening. If you get the pattern, you can start skipping steps. If you don't, keep doing it the way you need to. Yes. Don't worry about it. Okay. It's the same thing. Look. No, but Bethany, if I just put this over 1, what will I end up doing? I'll end up multiplying 4.5 times 4a, which is exactly what I did here. And I'll multiply 1 by 1, which gets me 1. Right. It's the same thing. Okay. So 4 times 4.5 is 18a. And then to get a by itself, we divide both sides by 18. And a is 1/18. Now remember, if it's up or right, it's positive. If it's down or left, it's negative. This one's to the right, so a is going to stay positive. And I get my final answer, 1/18. Y minus 0 squared plus 6. Yeah, that can be simplified, and I'm going to simplify it in a second. Holly?
If a was a negative number, but it opens to the right, change it, or would it?
A will always be a positive number the way we're setting it up. Because we're setting up a distance, which is always going to be a positive number, and we're setting it equal to 1 over 4a, which is positive. So it's always going to end up being positive. Then when you look at the direction, you decide if it's a negative or positive. Correct. I divided both sides by 18 to get, because I needed to isolate a. Yeah. This was 1.50. All right. Yes. 4.5 times 4? It is. What's 4 times 4? What's half of 4? What's 16 plus 2? All right. What's going on? Oh, you need to turn that in? Just turn on those back trio of desks. You can just be silent, please. Okay? All right. Let's try number 2. This is the same thing. It was that entire formula?
So that was it?
Yeah. Right. So you could simplify this further. This would normally be the answer. You could simplify it further because y minus 0 is just y. On a multiple choice test, this would be the solution. They wouldn't show this one. If it was multiple choice, this would be the solution. They wouldn't show it because y minus 0 is just y. I like this one because it shows me my h and k. I like that. So I don't mind this solution, but they would simplify it one step further. It's kind of like if you guys have ever done like odds. Sometimes, depending on the way you're talking about ratios and odds, not odd or even odds, but as in like the odds of something occurring, you don't necessarily reduce it, right? Because, for instance, if I said the ratio is 5 to 15, okay, the ratio is 1 to 3, but at the same time, it lets me know that the first time I observed, there were 15 things and I found 5. That does mean 1 out of every 3, but by keeping the original number, it informs me a little bit more. So sometimes reducing is good, sometimes reducing changes what we're observing. Anyhow. So you guys, I think, why don't you guys give this one a shot? No? Honestly, the way I'm teaching it, 1 through 6 are the same process. So if you'd like, I could do another one with us before we let you do it on your own. Okay, yeah.
So do we have to draw a graph for all of them?
You don't have to.
But then how do we know it's
Yeah, can you show us the way?
You draw the graph in your head. Yeah, you sit there and you think to yourself, the focus is here, the directrix is here, it opens to the right again, and it does. This one opens to the right again, and the distance between 1 and -4 is 5, so 2.5 is what 1 over 4a equals. But for me, drawing the graph really helps solidify all those concepts. Once I do a bunch of them, I'm okay to start letting that go. So the focus is at 1, 0. The directrix is at x equals -4. That means the vertex, so this distance here is 5, which means the vertex is 2.5 away. So we just pick one of them. I go to 2.5. That's -1.5 is my vertex. So here's my focus at 1, 0. So my vertex is at -1.5, 0. And that's my h and k. And then we know that this distance here is 2.5. And then I'm going to set that up and solve for a. So what's 2.5 times 4? I've got 250. And then I give you 250. You've got, and then 10. Yes. Yep, we'll get 1 over 10 is going to be my a value if you haven't got it. Okay, so we're going to get 2.5 is equal to 1 over 4a. If you're not able to skip steps, we multiply both sides by 4a. 1 equals 10a. Divide by 10. And a is 1/10. Yeah, that's really tiny, Elias. I'm sorry. Do you want me to zoom that in? Yes.
Will the A value always be a constant?
No. No. That's all I can say. So it's a sideways one, so it's going to be x equals. It opens to the right, so it's positive a value, 1/10. I don't mind you skipping to just y squared if it's y minus 0. Plus 1? Nope, plus minus 1.5. I used the focus on accident right there. I needed to use my vertex. Oh, oh, oh. Oh, 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 oh. By the way, I just have to comment because I looked at her right now and it triggered the memory. I'm talking about you. Yesterday, I came in during the second set of the volleyball match, and I have to say, when it comes to warrior expressions, when you guys, like, when something good happens on the court, Kaylee Huff, her expressions are so severe and so just passionate on the court when she's sitting there, You all right with that, Kaylee? Yeah. I mean, it was just like, you'd see a serve and like they'd fail and Kaylee'd be like, yeah! And I was just like, oh my gosh. Oh my gosh.
That's all we do is scream.
Yeah. That was a little redundant. I had the cutest picture of you yesterday. It was so cute. It's just so cute. All right. I've got the most amazing picture of Joseph and Callie standing side by side in the background.
Oh, how we look exactly alike. It's kind of weird. Our facial expressions, the way we're standing, everything's the exact.
Yeah. It was. All right. We good? Do you guys want to try number? Now, number 3, guys, notice that they give you the vertex. They give you H and K. They give you H and K for number 3. You guys are awfully silent today. Are you guys okay with this so far? A little louder. It's not a what the heck, Bethany. Don't exaggerate. Which way does this one open?
Right.
I don't know.
Oh, it's the Y.
Oh, it's a Y. So we have to notice that. We have to be careful. We get into ruts. We just start doing whatever we like, the same thing we've been doing. This one suddenly is not horizontal. This one's a vertical parabola. The directrix says Y equals. Y equals -2. So my directrix is a horizontal line. Correct, Bethany? Oh, Holly. Okay. And my vertex is at 0, 0. They did not give me the focus. They gave me the directrix and the vertex. Yes. But do we need it for the formula? We need the distance. We just need this distance to find A. What's that distance? 2. And they already gave us HK. And allow me to Elias this up for a second. Yeah. Remember, guys, on questions 1 and 2, they gave us a directrix and a focus, so we had to find the vertex. We were given the vertex, so we don't need to find it. Nope. Yes.
Okay, so for the vertex is what H and K are. Then
Correct.
why on number 6 did we use the vertex for X for H and K? Like why is it +6? Why wouldn't it be +1.5?
It should have been. I did it wrong then. Thank you, Cameron. Okay, I'm going to have to go back right here. I need to use the vertex H and K. That's 1.5. So she caught that I used 6. I used the focus on accident. I wasn't paying close enough attention. That should have been 1.5 for number 1.
One more question.
Yes.
So the X, why would we not put it in the formula when it gives us if it's X equals -3? Does it not matter that you don't?
That's the equation of the directrix. That's not the equation of the parabola.
Oh, okay.
Yeah. Okay. Schnittger's going for those on task and paying attention hero points. No, not unless it asks you to. If it asked you to find the focus, what would be the coordinate of the focus, Sione? Positive 0, 2, 0, 2 would be the focus. That's not called anything. There's no name for it, but that is our 1/4a. That distance is our 1/4a. You don't have to. James? What's up? No. Oh, you meant Bethany. So, all right. We good? Okay, HK are 0, 0, so 1/4a equals 2. Right over here. So multiply both sides by 4a. 1 equals 8a. Okay. And it opens away from the directrix, and it's going to open up. Right? So it's going to be a y equals. Yes, Elias? Was that not you? Was it Sione? What's up? Hmm? Simplifying that one, x minus 0 is simply x, so we get x squared, and it's plus 0, which is unnecessary. So once again, I'm okay with this as a solution, but if you simplify it, I'm okay with that too. And this would be the multiple choice, quote unquote, solution that you'd see on a test.
Mr. Bates, why was the last one like y?
Why was the last one what?
Y, like it was like y squared.
So because of the fact that y minus 0 is just y, that the squared didn't go away.
Y, right? Minus the x.
Oh, because it's about whether or not it's a vertical parabola or a horizontal parabola. Vertical ones are y equals. Horizontal ones are x equals.
Oh, it's because like the.
You can see it's going to open away from this line, and that's the vertex, so it's going to look like this. Well, because the directrix is horizontal. Bethany?
Where is the plus 0 coming from? Because I know it's 0, 0.
Yeah.
That node.
Mhm.
And since both H and K are 0, we don't need to.
Correct.
Why do you have to do the 1/4a?
So we determined way back on our notes. I don't have the notes up right now to pull them up, but I know what they look like. I was just going to bring them on the screen. But on the notes, we said if you look at the only time I've ever referenced this gigantic mess of a chart down below is to point out that the focus was, if we talk about, let's say, the vertical parabola, the focus, we're at hk, right? The focus is h comma k plus 1/4a. The directrix is k minus 1/4a, right? So the distance here was plus 1/4a. The distance to get here was minus 1/4a. So this distance must always be equal to 1/4a.
Because this is the base.
But we already knew that this one was 2, so I don't think.
This distance, no matter what it is, so if I'm just going to make a bunch of random ones. With that. Okay. And I did it. I don't want to. The distance from the directrix, so here, 2 equals 1/4a. This distance is always 1/4a. 3 equals 1/4a. 5 equals 1/4a. The distance from the directrix to the vertex is always 1/4a. Yeah, turn in 4-1 on the back trio of desks on your way out the door, please. I don't want to hear, I didn't hear you, and so can I turn it in Monday? So turn it in.